Liquids are measured in units of capacity, and in the U.S. customary system, these are commonly used units for measuring capacity. Fluid ounce, cup, pint, quart, and gallon. Now, we may or may not be familiar with the conversions for these, but here they are. 8 fluid ounces is equal to 1 cup. 2 cups is 1 pint. 2 pints is 1 quart, and 4 quarts in 1 gallon. Now, refer back to this chart often when going through the conversions if you're not familiar with them. When we're converting, for example, 36 fluid ounces into cups, we might think this way. Using this rate idea, we think of 36 fluid ounces as 36 fluid ounces times, now we make a fraction, and in the denominator we have fluid ounces because we want this cancellation opportunity. And in the numerator we're going to write cups. Now C is the symbol for cups. And so now we need this relationship between cups and fluid ounces. So we look back up here. Oh, 8 fluid ounces is 1 cup. All right, we write that over here. 1 cup is 8 fluid ounces. You see, if you forget, that's what you go through. So the fluid ounce business cancels here, and now the 8 with the 36. Well, let's see. 8 times 4 would be 32. We can go through the long division. We can use the calculator. But it turns out to go 4 times with 4 left over. So it's 4 4/8 or 4 1/2 cups in 36 fluid ounces. Here's an interesting conversion. It's 3 quarts into cups. Now, if we look at the list of conversions, we don't have a conversion directly between cups and quarts. Quarts were related to pints, and pints were related to cups. And so we might go through a couple of steps here to accomplish this. We could do it in one step, and that's illustrated in your textbook, but I'd like to show you another way. We can think of it like this, that 3 quarts, now I'm just going to think about it like this, that I'm converting to a smaller unit. The cup is a much smaller unit than a quart. So I'm going to convert down toward the cups. Now I know that a pint is smaller than a quart, so I'm going to convert to pints and then the pints into cups. So here's how that goes. So it's 3 quarts we think of as 3 quarts times a fraction with quart in the denominator, and in the numerator we're going to do pints because we have a relationship between pints and quarts. And from our chart over here, 2 pints make 1 quart. So 2 pints for 1 quart. And now the quarts go out, and we have 3 times 2, oh, that's 6 pints. You see, now we take the 6 pints, and we can convert that into cups like this. So it's 6 pints times a fraction with pints in the denominator and cups in the numerator. And from the chart, we know that it takes 2 cups to make 1 pint. So we write this. The pints go out. You see, and we have 6 times 2, 12 cups. So 12 cups then is 3 quarts. Convert 42 cups into quarts. Now, we're going the other way. We have very small units here, and we're going all the way up to quarts. But again, we can go through this step-by-step way of accomplishing the conversion by going through the pint idea. And it works like this. It's 42 cups we think of as 42 cups times some number of cups and pints in the numerator. So it is, let's see, 2 cups make 1 pint, you see, and the cups cancel here. Now we have the cancellation of the 2 with the 42. 2 into 2, 1. 2 into 42 goes 21. 21 times 1 pint is 21 pints. So we have converted the cups to pints, and now we convert the pints into quarts. So this is 21 pints, times pints in the denominator, quarts in the numerator. And let's see, it takes 2 pints to make 1 quart, so the pints go out. Now we have, oh, no cancellation here, so it's 2 into 21, you see, and that turns out to be the operation that we perform. 2 into 21 goes 10 times with 1 left over, so it's 10 1/2, and it's 10 1/2 quarts. 10.5 quarts. Suppose we want to subtract these. Once again, in this area of capacity, we have to borrow occasionally when we get involved with subtraction. 3 quarts can't be taken from 1 quart. We need some more quarts here to subtract from, and we go over here and borrow from the 4 gallons. So we're going to borrow 1 gallon, and once we borrow from the 4, it becomes 3. So we're left with 3 gallons. Now the 1 gallon that we borrow is really 4 quarts. So add the 4 quarts with the 1 quart we already have, and we have 5 quarts. Now we can subtract. 5 quarts minus 3 quarts, 2 quarts. 3 gallons minus 2 gallons, 1 gallon. So 1 gallon, 2 quarts. Consider this problem. 5 students are going backpacking in the desert. Each student requires 3 quarts of water per day. How many gallons of water should they take for a 3-day trip? Problem seems a bit complicated. We have 5 students, we have 3 days, and the amount of water needed is given as so much water per student per day. So how do we get into this problem? How do we organize it? Well, there are actually 2 very good ways to organize it. One way is to start with the notion of the need per day. You see, think about what's going on a per day basis. Every day we have 5 students needing 3 quarts of water each. So how much water is that? 5 students, 3 quarts for every student, so 5 times 3, that implies that we need 15, 5 times 3, 15 quarts of water needed per day. Now, I'm writing this down because I'm suggesting that you think your way through problems like this in a very similar way. That you actually write words down like this, rather than the strong tendency to just jot down numbers and multiply numbers and then try to keep track of what you've multiplied and where you are in the problem. You know exactly where you are if you associate the numbers with words. So you want to put a label on the numbers. When the problems get more complicated, you deal with those complications by greater organization. And that organization includes putting labels on numbers like this. So we're at the point where every day we need 15 quarts of water. So 15 quarts of water is needed per day. Now, we have how many days? We look back up here. It's a 3-day trip. So 15 quarts of water are needed for all of these folks every single day for 3 days. So 15 quarts per day times 3 days gives the total amount of water needed. 15 times 3, that's 45 quarts of water. And I don't need the S on quarts. QT is either single or plural. 45 quarts are needed. Okay. And now all we have to do is, have we answered the question? Is it 45 quarts that we need? Well, let's see, how many gallons of water should they take? Wait a second. We know that they should take 45 quarts, but we want this to be expressed in gallons. So we have to come out to the side and make that calculation. Let's do that. We have 45 quarts, and we want to change into gallons. So this is times. So we make our fraction here. It takes 4 quarts to make 1 gallon. So we have the cancellation opportunity here. It's 45 divided by 4. 45 divided by 4, we can go through the long division, use the calculator, whatever. But 4 into 45 goes 11 times with 1 left over. So it's 11 1/4 gallons of water that are needed. By the way, in this conversion, if you're going from quarts to gallons, again, you might go through the thought process to think, well, I'm changing into a larger unit. Larger units, there'll be fewer of them. To have fewer, you divide. You divide by the number of smaller units that it takes to make one of the larger. It takes 4 quarts to make a gallon, so we're dividing by 4. And that indeed is what ended up happening here. So 11 1/4 gallons. Now, I said there were 2 ways to think about the problem. One way is to first consider the need for water on a per day basis. Now, some students might say, well, gee, there's another way to do it. Another way to do it is to say, let's think about the need for water on the whole trip by each student. Well, each student, we might reason this way. We might say for each student, 3 quarts of water are needed per day for 3 days. So 3 times 3, 9 quarts of water are needed for every student. But there are 5 students. So 5 students times 9 quarts per student, you see, is 45 quarts. So again, we get to that 45 quart idea just using a different kind of logic pattern. And the 45 quarts is converted into 11 1/4 gallons in the same way that it was before.